So as we are continuing our study in antiderivatives and integration, one thing that happens sometimes is that you will get an antiderivative that looks something like this. And we're going to do this example actually. What we see is we have two distinct parts in this antiderivative, here and here. And what we have to do is look at it as two distinct parts. You can't really look at it as a substitution problem where one part of it is the derivative of the other part, because they're not. So what we have is a formula for situations like this. So u, integral of u times dv. And dv represents the part of the function that is the derivative of something else. And our rule is u times v minus the integral of v du. So how this applies to this particular problem is the way you pick u. In this problem, you're going to pick u, and it is not going to be the trig function. And this will be clearer later. If you have an exponential function like e to the x, it will not be e to the x. So let's talk about how we are going to handle this problem. So let's go to the next slide, and we're going to take the antiderivative of x squared times cosine x dx. Okay, since I did state that u could not be the trig function, that means u has to be x squared, and that means that dv is going to be cosine x dx. So back in the days when we were doing the product rule, we would take derivatives. Now, we're going to take the derivative of u, which is du over dx, and that gives us 2x. But I really just want du, and that gives me 2x dx. Okay? And then the antiderivative of cosine, that's sine. So we're going to substitute this into our equation. So we're going to take the u times the v and have x squared times sine x, and then we're going to subtract our v times du. And that gives me 2x sine x dx. Well, we still have these parts. We still can't separate them. So we're going to pick again and go, okay, now this time u is 2x, which means that du will be 2dx. And we're going to take our dv to be sine x dx. And then v is negative cosine x. So we're going to plug it into the formula again. And don't forget to bring down your x squared sine x minus. Okay, so we're subtracting the whole process, the whole u times v minus the integral of v times du. So let's start with the u times v. So u times v is negative cosine x times 2x. So negative 2x cosine x. And then we're going to subtract the integral of v times du. And we're subtracting a negative, so I'm just going to add that and make that 2 times cosine x dx, like that. And then our last step is to distribute that negative and take the integral of cosine. So I've got 2x cosine x, distribute the negative. The integral of cosine x is sine, so we keep the 2, hang on to that. And because this is an indefinite integral, we're going to add a c. Now, if you notice the x squared, I ended up having to do integration by parts twice. The larger your exponent, the more times you have to perform integration by parts, and that honestly could be a pain. So what we're going to do is we're going to learn another technique that will help us shorten this process. Okay, we're going to take the same problem, x squared cosine x dx, but we're going to do it a little differently. So as you see, I've made up columns, also known as tabs, and down this column, we're going to take u primes, derivatives, until we reach 0. And then this side, we're going to take antiderivatives until we reach the same line as the 0. So we're going to start with derivatives. So the derivative of x squared is 2x, and the derivative of 2x is 2, and the derivative of 2 is 0. And then we're going to take antiderivatives. So what did we take the derivative of to get cosine? We took the derivative of sine. And then negative cosine, and then negative sine. Now our next step here is that we're going to cross out the 0. We're going to cross out the first dv. And then we're going to multiply, 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 and add that product, subtract that product, add that product, and then plus c. And this process is the same no matter whether your exponent is a 2 or a 50. And that would be a pain also. So, antiderivative of x squared cosine x. So, we're going to multiply the x times the sine. So, x squared sine x. And then we're going to subtract the negative 2x cosine x. So that means we're going to add. And then we're going to subtract sine x, 2 times sine x. Actually, we're adding a negative, but. And then add c. And that's the same answer we got the first way. The larger your exponent, the more useful tabular integration is. And now we're going to do an example where we cannot use tabular integration because we have both a cosine and we have an exponential function. Now the reason integration by parts and tabular integration works is that you continue taking the derivative of what you've picked for u until it becomes a 0, and eventually you're just left with the integral of a trig function, and then you can take the antiderivative. The problem with ex and sin x is that you will never get a 0. And so what we're going to end up doing is we're going to do integration by parts twice until on the other side the integral of ex sin x shows up again. And then I'll show you what we do with that. It doesn't really matter which one you pick to be u and which one you pick to be dv, but when you do it a second time, you need to be consistent and pick the same type of function as your u and your dv. So I'm going to start with ex, and the derivative of ex is just ex dx. And so that means sin x dx is my antiderivative, and its antiderivative is cosine x, negative cosine x. So let's substitute it into our u times v. So there's u times v, negative ex cosine x. Then we're going to subtract v times du. Now, we're subtracting a negative, so we're going to add. So we've got ex cosine x dx. Well, the integral on the left side and the integral on the right side don't match. So we're going to have to do this process one more time. So we're done with these dv's. We're going to keep the u's. So let's get rid of those. Goodbye. Then we're going to pick a new dv. Well, this time I have a cosine. So cosine x dx. And v is sine x. Okay, so we're going to go through the process one more time. But what you need to do is make sure that you're bringing down the left side of your problem. It's going to be very clear why in a minute. So I've got negative EX cosine X. And then I'm going to add my integration by parts. So U times V is EX sine X. And then we're going to subtract the integral of V times du. So EX sine X dx. And, okay, let's look. Do I have something on the right side that matches this? I do. I have two of them. We are going to treat that integral like one large term, and we're going to add the whole thing to both sides. Like this. The whole thing, integral sign and all, gets added to both sides. So that means I have two integrals. So I'm going to have two integrals of EX sine X dx. And I don't like leaving negatives, so I'm just going to rearrange and put my sign in front. Okay. Well, if I were solving for a y, if that was 2y, then I would divide by 2, and so I want to do that. So let's divide by 2, like this. Put the whole thing over 2. And because this is an indefinite integral, there are no, I don't have an interval on my integral, then I'm going to add c. That's the basics of integration by parts. So I want to cover one more thing about how to incorporate the chain rule into this, and we're going to go to one more slide. Okay, let's say that I have the integral of e to the 2x times x. Well, I did state earlier that when you're picking your u and your v, don't pick an exponential function if you have something else. So in this case, du is dx, and dv is equal to e to the 2x dx. Now, how do we handle that exponent with a 2x? Well, if we were taking the antiderivative, which we are, we have to take into account that this e to the 2x, its exponent has a derivative. And what we do is divide by the derivative. That is the antiderivative of e to the 2x. If we were doing tabular integration and doing it one more time, we would continue to divide by 2. So the next time would be 1/4 e to the 2x. So substituting this into the problem, we have u times v. So 1/2 x e to the 2x. And then we're going to subtract the integral of 1/2 e to the 2x dx, because du is dx. And then take the antiderivative one more time. And remember, we're taking the antiderivative. 2x has a derivative, so we are going to divide by 2 again, which makes our 1/2 and 1/4. And then we don't need the dx, like that. And then we just add a c, and we're done. Now, what would this look like if I was actually taking a derivative of something? And I'm gonna set up one of the unknowns, but I'm gonna do it really quickly, and we're not going to complete the problem. So let's say that I have sine of 2x ex, and that I decided that sine of 2x was going to be my u, and ex dx was going to be my dv. Well, the way you handle du is a chain rule. So you're going to multiply by the derivative of the inside, which is 2. And then there's the derivative of the outside, which is cosine. If we were doing this process one more time, which in this problem you would have to do it twice, so if you let your u be this again, then if you took the derivative one more time, you would have negative 4 cosine 2x. So what you would be doing is continuing to multiply by the, and that would not be a cosine, that would be a sine. You would be continuing to multiply by the derivative of the inside. And that is integration by parts.